Mhm. Range is always going to be all real numbers. Asymptote is always going to be whatever h is. And in this case, h was 2. So my asymptote is x equals 2. My domain is x greater than 2. Yes, ma'am? This is for the translation. My asymptotes move when I translate. On the y equals log base 6 of x, my asymptote was 0. On the black one, my asymptote was 0. But the red one moved over by 2, so my asymptote moves over by 2. If it were x plus 2, my asymptote would be negative 2. What? X equals negative 2. Okay. One other little deal, have fun with those, is inverse functions. Oops, let's make this back to black. So if I want to write a logarithm, and I want to write its inverse, let's say I have y equals log base 2 of x. If you ask me to write its inverse, remember when we did inverses, you just switch the x for the y. So this is x equals log base 2 of y. Okay? I want to solve this function for y, so I try to change this into an exponential. Oh, well, I go 2 to the x, because the x is the exponent. Oh, that equals the y. Oh, now it's in proper function form. The y is isolated. So the inverse of y equals log base 2 of x is y equals 2 to the x. Okay. Yeah, that's fine. It's in function form. It's good. You switch the y and the x and then solve for y. The first line I wrote was switching the y for the x. The next line that I wrote was solving for y. Okay, of course they get a little bit harder. If I have something like y equals log base 3 of x minus 2, that minus 2 is not in the logarithm part. Since it's not in parentheses, that minus 2 is separate from the logarithm part. So in order to write its inverse, I need to move that 2 over to the other side and get y plus 2 equals log base 3 of x. And now its inverse is switch the x for the y. So that's x plus 2 equals log base 3 of y. Solve for y by doing this as an exponential. 3 to the power of the answer of the logarithm, which is this whole x plus 2. That's my whole exponent. So 3 to the x plus 2 is equal to that y, and there's my inverse function written properly. Everything on the other side of the equal sign will become the exponent. Yeah. When you're canceling out the log, the little number becomes the number that gets the exponent to it. Everything on the other side of the equal sign becomes the exponent. And the argument to the log, the number after the little number, becomes what goes on the other side of the equal sign.